Up to now, we have discussed about two types of reactions, normal chemical reactions and nuclear reactions. And we have to have an idea about balancing these reactions, how to balance any kind of reactions within our syllabus. And first, we have balanced chemical reactions. Actually, reactions are two types. Reactions are two types, chemical reactions and nuclear reactions. Chemical reactions and nuclear reactions. Under chemical reactions, we are talking about normal chemical reactions, and we have to learn about redox reactions. Redox reactions and nuclear reactions. What happens in nuclear reactions? One kind of element becomes another kind of element after the reaction. Like nitrogen element become carbon, like that. But in any kind of chemical reaction, we can't see such a manner. That means always nitrogen should be presented as nitrogen. When we are talking about normal chemical reaction, N2 plus H2 becomes NH3, ammonia. And each atom, number of each atom should not be changed within the reaction. That means number of nitrogen, 2 nitrogens are there, therefore this side 2 nitrogen should be there. And hydrogen, 2 hydrogen, 3 hydrogen, how to balance, actually 2 into 3, 6 hydrogens are there, therefore we have to add 3 to hydrogen. That is how normal chemical reactions are balanced. And within redox reactions, we have to balance in other way. Today our first topic is balancing redox reaction, especially in acidic media. Other than that, we have learned how to balance chemical reactions. In chemical reaction, in nuclear reaction, actually nuclear is broken. Nucleus is broken and new elements are formed, like carbon from nitrogen, like that. In the nitrogen nucleus, 7 protons are there, but in carbon 6 protons are. Here in this reaction, 1 proton has missed, like that. Such reactions we called as nuclear reactions. In nuclear reactions, some radioactive particles are emitted. Right? Radioactive particles are emitted, like beta particles, beta minus particles, beta plus particles. That means positrons, and gamma rays are emitted. Neutrons are emitted, and alpha particles are emitted. And these 5 particle types are emitted within nuclear reactions, emitted or absorbed by some reactants. And what happened in beta emission? It looks like this: 0 minus 1. Charge is minus 1. 0 is the mass. Here, opposite to that, plus 1 and 0. Here, gamma 0 0. Here 1 0. Here 2 and 4. Correct? Plus 2 and 4, like that. Alpha 2 plus helium 2 plus nuclei, like that. Plus 2 and mass number is 4. Then how to balance this reaction? How to balance this reaction? Beryllium 9 4 plus gamma. Here gamma is gamma absorption. Beryllium alpha radiation is absorbed by, alpha particle is absorbed by beryllium and becomes beryllium 8 4 isotope. And what about the remaining particle, X? We have to find the remaining particle with its proton number, atomic number and mass number. All the mass numbers should be total of both sides. The total of mass numbers, totals should be same. That means 9 plus Gamma absorption means 0 plus 0, 0 and 0. Here 9 plus 0 into equals to 8 plus x. Here A and B, 8 plus A. Here A means 1. A means here 1. And 4 plus 0 equals to 4 plus B. B means 0. It should like this. That means neutron emission is occurred. Correct? It looks like this. 1, 0, neutron. Neutron emission is happened like that. Another example. Another example. 209, 83 bismuth plus deuterium nuclei. They are fused with each other. And ABX. And we have to find this X particle with 1 hydrogen isotope emission. And 209 plus 2 equals to 9 plus X. A plus 1. And here A is equal to 109 means 211. 11 equals to A plus 1. A is equal to 210. Here it should 210. Here 83 plus 1 equals to B plus 1. Here B is equal to 83. It looks like this. That is how nuclear reactions are balanced. Today our topic is balancing redox reactions. Actually, we know about balancing normal reactions like that. H2 plus Cl2 becomes HCl. Here, 2 hydrogens, it should 2 hydrogens, 2 chlorine, like that, normal reactions. Today our topic is balancing redox reactions. Balancing redox reactions. To balance redox reactions, you have to have idea about oxidation numbers, how to find oxidation numbers of each element in the reaction. First of all, redox reactions. What are the redox reactions? What do you mean by redox reaction? It can be divided into 2 parts. Red plus ox. Red plus ox means redox. Red means reduce, that means the reduction. Ox means the oxidation. Oxidation. Red means the reduction. Ox means the oxidation. What do you mean by reduction? Reduction of element is, that means decrease in its oxidation number during the reaction. And decreasing of oxidation number. Species, and reduction means reducing means decrease in oxidation number. Example, MnO4 minus becomes Mn2 plus. What about the oxidation number of manganese? Manganese here, or total value should -1. Oxygen normally takes -2. -2 into 4 means -8. Total becomes -1. Therefore, it should take +1, +7 here, +2. Here you can see 2 electrons have taken by 5 electrons have taken by and 5 electrons have taken by manganese and becomes Mn2 plus. Mn2 plus. Otherwise, oxidation means increasing oxidation number. Increasing oxidation number. Increasing oxidation number means oxidation Fe2 plus become Fe3 plus. Here oxidation number is +2, here +3. After removing 1 electron, iron 2 plus become iron 3. Iron 3 plus, its oxidation number has increased. It is called as oxidation. And oxidation doing species is called as reducing agent. Due to this oxidation of this species, it helps to reduce the other species. Therefore, normally oxidation occurring species we called as reducing agents. And reducing agents reduce others by oxidizing itself. I think you can understand what I'm saying. Reducing agents are agents which can be oxidized by itself. That means helps to reduce others. And reducing agents reduce others and they decrease others' oxidation numbers. So reduction occurring species we called as oxidizing agents. Oxidizing agent means they oxidize others. They oxidize others. How they oxidize others? How they oxidize others? Taking the removing electrons and taking the removing electrons from reducing agents. Therefore, oxidizing agents, normally oxidizing agents do the reduction. Reducing agents do oxidation. So, we have to balance these redox reactions in acidic medium, basic medium, and the neutral medium. Normally, we need balancing redox reactions in acidic medium. Therefore, first of all, we consider about balancing redox reactions in acidic medium. Okay, we will take an example first. We take this example, Fe2 plus MnO4 minus into Fe3 plus Mn2 plus. We have to balance these equations in the acidic medium. Very easy. First of all, we have to find the oxidation number of each species. First step is what? Find the oxidation number of each species among reactants and products. Among reactants and product. How we take oxidation numbers? Here, manganese, it has +7 oxidation number. Iron 2 plus directly +2. Iron 3 plus directly +3. And manganese 2 plus directly +2. Here, manganese +7, +2, +3, +2. Then, the second step is identify oxidizing and reducing agents. Identify oxidizing and reducing agents. Where oxidation takes place, it is called as a reducing agent. Where the reduction takes place, it is called as an oxidizing agent. Anyway, manganese +7 becomes +2. Therefore, the reduction takes place. That means it is called as the oxidizing agent. Here the oxidizing agent is MnO4 minus. That means the reduction takes place. Here oxidation takes place. Correct. Then identify number of passing electrons balance. And balance, that means here on this line, we write number of passing electrons. Normally plus 2 to plus 3 means only one electron, therefore we write electron, one electron. Here 7 to 2 means 5 electrons, we write it in this manner. And within redox reaction, the oxidizing agent, that means the species which the reduction takes place, should take all the electrons from the reducing agent. That means number of electrons of this reaction, this half reaction, should be equals to number of electrons of this half reaction. Therefore, to balance electrons, we have to multiply 1 into 5. That means 5 electrons are there, 5 electrons are there. We have to multiply relevant species by 5 here. Now, we have balanced all the atoms. 5 Fe, 1 manganese. Then we have to, the fourth step is what? Balancing. As it is an acidic medium, the fourth step is balance ionic charges by using H plus ions. Normally H plus ions takes plus 1 charges. Remember that. Left side of the arrow here, minus 1 charge is there. Minus 1. Here 5 into plus 2 means plus 10 charges are there. The overall charge is plus 9 this side. Plus 9 this side. Here 5 into 3 plus 15 plus 2. That means plus 17. Plus 17. What is the difference? What is the difference? 8 plus charges additionally there. 8 plus charges plus 8 charges additionally plus 8 charges are there. To balance this 8 plus charges, we can only use H plus ions. H plus means 1 plus here 8 plus charges are there. To balance these 8 plus charges, we have to add 8 plus charges to this side. That means 8 H plus charges should be added. 8 H plus charges should be added. The final one, balance H plus using water. Here 8 plus H plus are there. We can balance these 8 H plus by using water. 4 water molecules should be required to other side. 4 water molecules should be required to other side. Here you can see 8 H plus, 1 manganese, 4 oxygen, 5 iron. We have balanced our reaction. Right? Then how we can identify this equation? We have to write half reactions in our exam. And here we can write oxidation half reaction. Fe2 plus become Fe3 plus. It is the oxidation half reaction. Oxidative half reaction. And plus 2 into plus 3 means 1 electron is removed. This is equation number 1. And reducing half reaction reducing half reaction means MnO4 minus into Mn2 plus. Here oxidation number is plus 2. Here oxidation number is plus 7. Plus 7. 5 electrons are taken. 5 electrons are taken by MnO4 minus and becomes Mn2 plus. 5 electrons are taken. This is equation number 1. We have to balance these two equations. Therefore, 5 electrons here, here 1 electron. Therefore, 1 should be multiplied by 5. All the species should of equation number 1 should be multiplied by 5. 5Fe2 plus into 5Fe3 plus 5Fe is equation number 3. Equation number 3. Then we can add 2 and 3 equations. The next step is 2 plus 3. And 2 plus 3. Here 5 electrons plus MnO4 minus. Left species of the arrows should be added first. Here plus 5Fe2 plus into Mn2 plus 5Fe3 plus 5 electrons. 5 electrons. And before that, we have to balance their ionic charges. 5 electrons and 1 charge means minus 6. Minus 6. And minus 6. And here plus 2. That means 8H plus should be there and 4H2O should be there. Right? 4H2O should be there. Here 5 into 2 means plus 10. Here 5 into 3 means plus 15. Here 5 electrons are there, minus 5. Therefore, plus 10 cancel. Plus 10 cancel. Therefore, we have to add this 8H plus into the left side. Right? This is the most easy step, and they are very boring steps. Therefore, you have to practice this particular step, and by using that, we can write half reactions by looking at this. Therefore, make sure to practice this method. And here, and 5 electrons and 4 H2O. We can remove, we can cancel 5 electrons and 5 electrons. We can take the final answer as, this one, 8H plus MnO4 minus plus 5Fe2 plus into Mn2 plus 5Fe3 plus 4H2O. You can see both answers are same. This is the very actually very easy. This method is very easy compared to this. Therefore, you have to practice this method. Let's take the second example. PbO2 plus H plus SN2 plus into Pb2 plus SN4 plus. And here we can say lead is in Pb plus 4 form. Therefore, for our listeners, Pb plus 4 SN2 plus, here Pb plus 2 SN4 plus. And what about our first step? We have to identify the oxidation numbers of each species. Oxidation numbers of each species. Oxidation number of each species. Here plus 4, here plus 2, here plus 2, here plus 4. Then we can find oxidizing and reducing agents. You can see lead plus 4 to plus 2 plus 2 to plus 4. And here 4 to 2 means 2 electrons. 2 to 4 means 2 electrons. Electrons are balanced. Electrons are balanced. Then we can calculate their charges. Plus 4, plus 2, plus 6. Here also plus 6. Here also plus 6. Therefore, it is already balanced. It is already balanced. No need to balance further. Next step, next example. Mn2 plus BiO3 minus into MnO4 minus plus Bi3 plus in acidic medium. And here plus 2, here all should minus 1. Minus 2 into 3 minus 6, therefore it should get plus 5. Here all should minus 1. Minus 2 into 4 minus 8, therefore it should get plus 7. Manganese 2 plus Bi plus 5 plus 7 and here plus 3. Then what we have to do? Identifying oxidizing and reducing agents, manganese and here bismuth. And how many electrons? 5 electrons. Here 2 electrons. To balance electrons, 2 should be multiplied by 5 and 5 should be 2. That means 2 and here 2. Here 5 and here also 5. Then we have to balance charges. 2 into 2 means plus 4. Here minus 5. That means minus 1 is remained. Minus 2 and plus 15. Plus 15, that means plus 13. Plus 13 minus 1 means here plus 13, here minus 1. We have to add plus 14 to this side as H plus. And here 7H2O. Now we have balanced our equation. We have balanced our equation. Yeah, how we can identify oxidizing half reaction and reducing half reaction. Oxidizing half reaction. Oxidizing half reaction means BiO3 minus Bi3 plus. Plus 2 electrons. Reducing half reaction, Mn2 plus take 5 electron and becomes MnO4 minus, like that. Next one. Next one. As2O3 plus MnO4 minus into As2O5 plus Mn2 plus. And first of all, we have to balance atoms. As2 balance, Mn balance. Then arsenic, manganese plus 2, manganese plus 7. Here arsenic plus 5, because minus 2 into 5 minus 10. It is balanced by 2 arsenic plus 5 each. Here plus 3. Here and here. Here you can see 3 to 5 by 2 arsenic atoms. That means 3 to 5, 2 arsenic atoms means 2 electrons into 2. That means 4. Here 5 electrons. 5 electrons and 2 into 2 means 4 electrons. 4 electrons. Here 5 electrons. We have to balance 4 and 5. Therefore 4 into 5 and 5 into 4. Therefore 4 and 4. Here 5 and 5. Then we have to balance the charges. Here no charge. Here minus 4. Here plus 8. Plus 8 minus 4. Here minus 8 and we have to add minus 8 plus minus 4 plus 12. H plus 6H2O. It should like this. Another example. Cr3 plus S2 O8 2 minus into Cr2O7 2 minus plus SO4 2 minus in acidic medium. We have to, first of all, we have to balance the atoms according to our I. That means chromium and here chromium. 2 chromiums should be there. S2 and here 2S should be there. Then identify oxidation numbers. And plus 3 here all minus 2. Minus 2 into 8 minus 16. Minus 16 and plus 2 means minus 2 means it should take what? Minus 2 into 8 means minus 16. And here minus 2 should be there. Therefore minus 14. Then it should take plus 7. Plus 7. And here all should take minus 2. Minus 2 into 7 minus 14. That means minus 12. Plus 12. Each should make plus 6 here. Plus 6. Cr and here Cr. Here how many electrons? 3 into 6 means 3 electrons by 2 chromium atoms. Therefore 6 electrons. And 7 into 6 1 electron by 2 sulfur atoms. Therefore 2 electrons. And 6 electrons 2 electrons should to balance as 6 electrons. 2 should be multiplied by 3. And 3, already 2 is there. 2 into 3 means 6. 6 here, 3. Then no need to multiply any other number. Then we have to balance charges. 2 into 3, plus 6. Here 3 into 2 minus 6. Balance. Minus 2 minus 12. Plus minus 2 plus minus 12 means minus 14. Minus additional minus 14 is there. Therefore, we have got plus 14 as H plus. Then 7 H2O. That is how the reaction is balanced. Next example, Fe2 plus Cr2AO7 2 minus Cr3 plus Fe3 plus. Identify each oxidation numbers. Plus 2 here, plus 6 here, plus 3 here, plus 3. Right? One iron, chromium 1, 2 chromiums, therefore we should take 2 chromium. Then iron 1 electron, here chromium 3 electrons by 2 atoms means 6 electrons. We have to balance electrons, therefore 1 should be multiplied by 6, therefore it should be multiplied by 6. Then we have to balance charges. 6 into 2 means plus 12. Here minus 2 plus 10. Balance plus 10. Here plus 6 plus 18. That means plus 24. And additional 14. Additional 14 H plus is there. Additional 14 H plus is there. Therefore, we have to balance additional H plus into this part. Therefore, 14 H plus should be added. Therefore, 7 H2 is should be added. Final example for balancing equations in acidic medium. ClO minus plus Fe2 plus into Cl minus plus Fe3 plus. ClO minus. Here ClO minus minus 1. Here minus 2. ClO minus. ClO2 minus. ClO2 minus. It should plus 5. Here minus 1, here plus 2, here plus 3. Then how many electrons? 1 electron. Here 6 electrons. Therefore, it should be multiplied by 6. Then we have to balance charges. Minus 1, 6 into 2 means plus 12. Here minus 1 means plus 11. Here minus 1. Here plus 18. Plus 18 means plus 17. Plus 17. Here plus 6 additional charges are there. Therefore, to balance it, 6H plus should be added and 3H2O should be added to this part. That is how equations are balanced.